Would you see the slide? Would you see the slide?
Okay, sir.
Sir.
Okay. Process control. Before we move on into the subject, we must know that what is process and what is control. Process is nothing but a science of automatic control denotes an operation or series of operation on fluids or solid materials during which the materials are placed in a more useful state. The process may be single operation or cascade connection of more than two operation. Next one is control. Automatic control. Automatic control is the maintenance of desired value of a quantity or condition. What we are trying to say is we just want to maintain the desired value. For example, if you want to maintain the tank level is 50%, it could be maintained by the control system. Otherwise, if you want to maintain the tank at 90 percentage of height, that value also you could maintain. I mean that what is your desired value? According to that, you can do the or you can run the process with the help of control system. The objective of the subject is we should run the plant. How the plant is running? The plant receives the raw material, uses the available sources of energy and produce the product in the most economical way. Plant receives the raw material, utilizing the available sources of energy and producing the product in the most economical way. To meet the requirements, we need to meet some requirements. What is the necessity or requirement of process control? The process control is essentially deciding how much the input must be changed to correct any deviation in the output from the desired value. The process is taking input. The process is taking input. According to that input, the process is giving output. Suppose you want to change the output of the process, that time you need to change the input. Since according to the what you are giving as input, depends upon that only the output value is changing. Okay, the output of the process depends upon the input value. So if you want to make any changes in the output, that time you can change the value of the input. That's the key idea. Requirements. What is the requirement for the process control? First, primemost requirement of process control is safety. Safety is very essential one. Safety is concerned human safety, environmental safety, and instrument safety is very important. For example, if you are taking or if you are considering reactor, the reactor should operate within the pressure level of 100 psi G. The reactor should act within the range of 100 psi G, or the maximum operating pressure is 100 psi G. That time you should introduce some external intervention. That external intervention is nothing but your control system. It will be useful for maintaining the pressure below the or lower than the maximum operating pressure of 100 psi G. Second point, product specifications. We need to make the uniform quality as well as quantity in the product what you are making. Production specification. You need to make the uniform quality and uniform quantity at your desired level. It could be possible only by the control system. Third one is environmental requirements. Number of state and federal laws which enforce to maintain. Example, to maintain concentrations, chemicals in the effluent stream. Chemicals in the effluent stream. Second one is sulfur dioxide concentration in the steam which is rejected to the atmosphere. From the industry, we are rejecting the or leaving the sulfur dioxide to the atmosphere, but it must be at a particular value. That one is instructed by the state and federal laws. According to that only we should run the plant. For that purpose also, we are introducing external intervention or control system in the chemical plant industries. Third one is wastewater, which is returned to the river or lake. In industry, lot of wastewater is produced. That wastewater leave to the river or lake. But the state and federal laws giving instruction, you should leave the wastewater to the river, lake up to certain level only. Okay, according to that only we should leave the wastewater or according to that only we can leave the wastewater to the river or lake. Otherwise, you should recycle the wastewater, then only we can allow the water to mix with the river or lake. In that place also, the control system is coming into picture. Fourth one is operational constraints. The plant have certain constraints inherent to the atmosphere. First one is distillation column. In distillation column, the flow should not be flooded. Second one is tanks. Tank should not overflow or go to dry. Tank should not overflow or go dry. Third one is the temperature in a catalytic reactor should not exceed the upper limit. Temperature in a catalytic reactor should not exceed the upper limit, because beyond that temperature, the catalyst losing its property or the catalyst get damaged. Fifth one is economics. Economics, we should get maximum profit with the minimum cost. We should produce the, or we can get the, we should get the maximum profit with the minimum cost. These are all about the requirements to meet the plant objective. These are all about the requirements to meet the plant objective. To maintain all these requirements, there is some external intervention is required, and that external intervention is nothing but a control system. Okay, generally issues occurred in the process control industries. The influence of external disturbances. The influence of external disturbances. What is external disturbances? Okay, the fluid is coming into the plant and leaving as a output. Okay, the incoming fluid may be changing with the flow rate or temperature. This and all disturbing the process. This and all we can call it as external disturbances. Second one is the stability of the chemical process. Stability of the chemical process means at steady state, the process will be maintained at a particular value. That value should be maintained. Okay, some places the steady state value will be fluctuating. That time we need to introduce external intervention to bring the system to the stable condition. Third one is the performance of a chemical process. We should optimize the performance of the process. Okay, what is the need for control system here? To suppress the effect of disturbance. The external disturbance must be suppressed with the help of process control. Ensure the stability of the system by process control. Optimize the performance of the system by process control. How the process control is useful to face the issues. Okay, how the process control system is useful in the useful in dealing the issues occurred in the process control industries. That one only we are going to see one by one. External disturbance. First case is external disturbance. For explaining the external disturbance, I take the example heating tank system. Heating tank system. This one is the tank. Okay, in the tank, the liquid inlet liquid is coming along with the flow rate of F suffix I and temperature is T suffix I. And liquid leaving from the tank is flowing with the flow rate of F and temperature at T degree centigrade. Okay. For heating the liquid in the tank, I am using coils. Okay. Through that coil, we are admitting or allowing the steam with the flow rate of F suffix St. Here, our objective is to maintain the liquid in the tank or outlet liquid of the outlet liquid temperature. To maintain the temperature of the liquid in the tank or outlet liquid temperature, you should maintain at the desired value. That one is the first objective of the process. T equal to T suffix D. This T you just want to maintain at your desired level. If you want to maintain the temperature at 300 degrees centigrade, you could maintain. If you want to maintain the temperature at 200 degrees centigrade, you could maintain. So, according to your desire, you could maintain the liquid temperature. So, your first objective is T is equal to T suffix D. Second one is you could maintain the level in the level of liquid in the tank. You could maintain the level of liquid in the tank at your desired level. Okay, here second objective is H is equal to H suffix D. Okay. Initially, you should follow the startup procedure. Initially, you should follow the startup procedure. Startup procedure means first we should switch on the pump, then you need to admit the inflow, then after filling certain level only, you should admit the steam to heat the liquid, then you can open this outlet to leave the liquid. Like that, some startup procedure will be there. You should follow that procedure. Then you are allowing the process to run. Then after certain time, the process will reach the steady state. The process will reach the steady state means the liquid is coming along with the particular value. The liquid is coming along with the particular value of temperature, and the level will be maintained at a particular liquid height. The level will be maintained at a particular height. Okay, this value will be maintained at the steady state. Then, if any changes occurred, if no changes occurred in the inlet liquid flow and inlet liquid temperature and inlet steam, if this and all external inputs, these external inputs is these external inputs and all not at all changing, that time no change will be happen in the outlet liquid flow temperature and outlet liquid height. There is no changes will be happening over there. But this is not the case in practical. What will happen? This F suffix I, inlet flow rate will be getting changed, or sometime inlet flow temperature will be getting changed. Because of this kind of changes, this process output, I mean that the outlet liquid temperature may be getting changed, or level of liquid in the tank, level of liquid in the tank will be getting changed. That time we need to bring it back to the desired level. We need to bring it back the value to the desired value. For that, we need to introduce some external intervention, that is nothing but your control system. If there is no change of any input variables, if there is no change of any input variables, no changes happen in the F suffix I and T suffix I, then the process will remain at a steady state. The process will run at a steady state and there is no need of any control system. But This is not the case in practical practice, but this is not the case in practice. Okay, that time we need to introduce the control system. How can we introduce the control system? First of all, we need to make the measurement of present temperature here. That temperature is T. That value will be measured with the help of thermocouple. Okay, that value will be given to the summing point. There you are giving your desired temperature value. There you are giving your desired temperature value. So that comparison will be taking place. Comparison will be taking place. T suffix D minus T. That deviation value E is coming over here. That error value is given as input to the controller. Okay, according to that error value, the controller will estimate or calculate the control action. That control action should be implemented to the process through the control valve. Okay, this is the operating procedure of control system. Here, here we are taking two cases. First case is E is greater than 0. E is greater than 0. Already I told E is nothing but T suffix D minus T. E is greater than 0 means here T suffix D value is, I mean that desired temperature value is greater than the measured value of temperature T. Okay, at that time you should open that wall much and you should admit more steam to increase or boost up the temperature inside the tank. Then second case is E less than 0. At that time, the desired value of temperature less than the measured value of temperature in the tank. That time, the wall should be closed to reduce the flow of steam to the tank. Okay. Suppose F suffix I is increasing. I mean that inlet fluid flow rate is increasing. That time the temperature of the liquid in the tank will be decreasing. At that time we need to increase the steam flow rate admitted into the tank. Next one is stability of a process. Here in x-axis we are taking time, y-axis we are taking the output. That output may be temperature T or concentration. Okay. Initially, the output value will be at a steady state. Then at time T equal to T naught, at that time we are introducing the disturbance. We are introducing the disturbance. X is disturbed at T equal to T naught. That time X returns automatically to the steady state after few oscillations. Then we could see the response. You could see the response after few oscillations. The output value will be reaching the steady state value. That kind of process we can say stable process or self-regulating process. This kind of cases we need not introduce the external intervention or control system. The case 2 if we are taking, okay, initially the process at steady state, at T equal to T naught, we are introducing external disturbances. That time the output go to oscillate and it do not or does not come to steady state. It will increasing exponentially. That time we can say this kind of process is unstable process. In that condition, we need to introduce external intervention or control system. Next one is optimize the performance of the process. Here I took the example of continuous stirred tank reactor. Continuous stirred tank reactor. Here two consecutive process action is taking place. This one is exothermic reaction. Okay, A is the reactant. From that A, desired product P will be produced with the undesired product C. Here, the economic objective is maximize the profit. Maximize the profit. The profit depends upon the three factors. Okay, maximize the profit pi is equal to integration of 0 to t of b comma a comma c. Okay, where t is nothing but your operational time, b is nothing but revenue from the sales of product. Revenue from the sales of product. From the plant, we are producing some products. After selling those products, how much we are getting the revenue? That revenue is nothing but revenue from the sales of product. We can specifically mentioned by B. A is nothing but for producing that product, what is the raw materials? I mean that reactant what we are using. That one is specified by the letter by A. Next one is this one is exothermic reaction. Enormous amount of heat will be produced. The heat must be taken out. Okay, for that purpose, we are using the coolant. The coolant expenses is nothing but C. C is nothing but your cost of coolant. So, if you are effectively utilizing the coolant and the reactant, that time you can get maximum profit, by the way of which you can maximize the profit. Here also we need to introduce the external intervention. Next topic is variables. Variables can be classified into two types. One is input variable, another one is output variable. Input variable can be classified into two types: disturbance or load variable, manipulative variable or adjusted or control variable. The output variable can be classified into two types: measured output, unmeasured output. Another variable is controlled variable. This may be fall in the category of measured output, rarely unmeasured output. Process variables. The controlled variable of the process should be that the variable which most directly indicates the desired form or state of the product. Okay, this one is nothing but output of the plant. Second one is the manipulative variable of the process is that of variable which is selected for the adjustment by the automatic controller so as to maintain the controlled variable at a desired value. We need to maintain the output product at a specified value. For that, which variable we are selecting? That variable is nothing but your manipulative variable. Okay, the variable which is disturbing the process, that variable is nothing but your load variable. Okay, we can get still more clarification on the variables with few examples. First one is liquid tank system. Liquid tank system, here our objective is to maintain the level or height of liquid in the tank. Our objective is to maintain the height of liquid in the tank at your desired value. So here the objective is h is equal to h suffix d, where d is nothing but desired value of height. Okay, here we are going to control the height only. So h we can take as controlled variable. Okay, now we are making the pair of controlled variable and manipulative variable. CV is nothing but your controlled variable, MV is nothing but your manipulative variable. Okay, here the controlled variable is nothing but your height of liquid in the tank. Then if any changes occurred in the height, we need to bring the value to the desired value. For that, what are the values we are using? F suffix I, comma, F suffix not. Fi is nothing but your inlet flow rate. F naught is nothing but your outlet flow rate. Here, the input variables are F suffix I and F suffix naught. Why we are putting F suffix naught is output? Okay, here F suffix naught is leaving us output only. Okay, so most of the people will think this is output only, then why we are keeping that value in the input variable list? Okay, there will be reason is that already we listed the variables. According to that, manipulated variables fall in the category of input variables only. Okay, manipulative variable fall in the category of input variables only. Here, by adjusting the F naught, we can maintain the liquid level in the tank. So we can say this one is manipulative variables. Sometimes we can use F naught to maintain the liquid level in the tank. Otherwise, in that situation, we can say that one is manipulative variable. That time we can categorize the F naught as input variables. Suppose instead of adjusting the F naught, if you are adjusting the value of F suffix I, that time F naught is fall under category of output variables. Okay. Now, with the help of F naught, how can we maintain the liquid level in the tank? That one we can see now. This is for tank. Okay. The tank height must be measured with the help of level sensor. The measured height will be given to the summing point. There you are giving the desired height value of the liquid level in the tank. There comparison will be taking place. Find the error value. That error value will be given as input to the controller. Now the controller calculates the control action and implement the control action to the tank through the control valve. Your next example is heating tank system for explaining the manipulative variable and the control variable. In heating tank system, in heating tank system, uh, the objective of the process is you could maintain the liquid temperature at a desired value. So T is equal to T suffix D. Liquid temperature must be maintained at a desired value. T equal to T suffix D. Then tank height, liquid liquid level must be maintained at a desired value. H is equal to H suffix D. So these two are controlled variables. So I'm making the control pair. Manipulative variable, controlled variable. The controlled variable, first controlled variable is temperature of liquid in the tank, height of liquid in the tank, H. These two are controlled variables. How can we change the, how can how can we correct the changes in the controlled variable? By using flow rate of steam. By using flow rate of steam. So the flow rate of steam is nothing but your manipulative variable here. How can we correct the changes in the liquid level in the tank? Two possibilities are there. One is inlet flow rate you could change or outlet flow rate you could change. So these two are manipulated variables. Okay, now you list the input and the output variables. Input variables and all f suffix I, f suffix st, t suffix I. Okay, these are input variables. Okay, here f if you are using as manipulated variable, that time we can the f is fall under category of inputs. Next we are taking outputs. F is f outputs are f t and this height h liquid level, where f suffix I, f suffix st are manipulated variables. T suffix I is nothing but your load variable. T comma kh controlled variables. With this, we come to end of our session.